Hello, we're going to do 2.2 outside of class examples is what we're going to be looking at. Here's my paper view. I started off on paper view. Ah, where did my mouse go? There it is. And so this is problem 46. And what they've said to us is for the graphs of the function f and its derivative f prime are shown. So they have two graphs there, and they want to know which is bigger, f prime at -1 or f double prime at 1. And so we're going to see if we can answer that question. The first thing that we have to do is we have to figure out which graph is which. And um, and and so what I usually do is I usually start off with a guess. So I decided I would use this die as my guesser. And so one of these graphs is f, and the other graph is f prime. And so I'm going to use, if I roll a 1, 2, or a 3, then this is the graph of f. Otherwise, it'll be the graph of f prime. So I rolled a 3, so I'm saying that I'm going to have this be the graph of f. And then that would mean that this is the graph of f prime. And this is just a guess. I don't want anyone to think that that is for sure true. I'm just checking it out. So what I want to do is I want to go all of the places that f is at 0. The slope of f is at 0. I'm going to not have this going through my graph. I'm going to just point from below here, f prime. Okay, so I'm saying that this is f, and so there's a 0 right here. At that spot, the slope is 0. And I'm following f, and right here, so this is f, and the slope is 0. And you can see that these are matching. The f prime should be on the x-axis. That's where y is 0, on the x-axis, right? And so far it's matching. Okay, so we said this was f. I'm finding another 0. So I would go and look for all the zeros and all the undefines. Now, there's not going to be any undefines. Undefines for f, the derivative being undefined, happen at corners and at asymptotes, any breaks in the graph, any discontinuities, right? And I don't have that. And so, but I notice all the zeros are lining up quite nice. So the slope here is 0, and we notice if this is the graph of the slope, that it's at 0, right, on the x-axis. And so that's looking pretty good. Okay, now the other thing that we would want to make sure of, you notice here that f is going uphill. And so since f is going uphill, that means that the slope for f is positive, right? The slope of the graph is positive if you're going uphill. And so that would mean that f prime would have to be completely above the x-axis. That's where it's positive. So I'm looking here, f is going uphill, so that means f prime should be positive. But when I look at what f prime is doing in that spot, I notice that it is below the axis, which means it is negative. So that tells me that my guess that this die picked was not right. And so now I'm going to relabel them. And since there's only 2 of them, I think that I'll probably have it right now, because I kind of worked until I found a contradiction, right? And so I'm going to erase all this. I didn't know which one was which. So I was just trying to figure out, hey, is that one, did that one work? Now I might have found the one that worked first, but I used a die. So, okay. So here I'm asking myself, is this f prime? And then that would mean that this one is f. So we're going to do the same thing that we did. We're going to find zeros and see if it's 0. So right here is a place where the slope looks to me like it's 0, right, on the f graph. And f prime is at 0. Then I'm going to go here, and it does look like it's 0 here. And I'm kind of looking with my eye, and I'm noticing, yeah, it goes right. The f prime is right on 0. So that's good. So let's continue along here. Here's another 0, a place where the slope of the f graph is 0, and it looks very much like we're at 0 there. And then here the slope is 0. Oh, wait, did I get on the wrong graph? I did. Let me keep on this graph. The slope is 0 and it looks like 0. So I didn't get any contradiction there. Now I'm going to do my increasing, decreasing and see if I get any contradiction. Again, I don't have any place of where it's undefined. And so I'm not thinking that I'm going to have that. And so now I'm on, okay, if this is F here from this dot anyway, right there, F is uphill. That means F prime should be positive. And I notice, so from here on, I'll draw the line just so that you can see, from here on, F prime should be positive. Positive would mean above the x-axis. So because the slope, I know that F is below the x-axis, but I'm not looking at that. I'm looking at its slope. And since it's going uphill, its slope is positive, and then this is supposedly a graph of the slope, and I notice it is positive. So I go all the way here, it's positive, and it's all above the x-axis. And then this is where F starts to go downhill. That means that F prime should be negative. And I notice, well, this is going downhill and F prime is negative. So downhill, F prime is negative, downhill, F prime is negative, all the way to here, and F prime is negative. And then here, I'm going to go back uphill, F prime is positive. So I'm pretty much convinced myself that I have them labeled correctly. And so now, let's see what we were supposed to find. So now I know which one is F and which one is F prime, right? And I just started a guess and got it wrong. Maybe it was good that I got it wrong the first time. I just used the dice. And okay, so I'm going to look at F prime at -1. So I'm looking for, I know this is kind of smeared, but I think that's 1 right there. And I think that this spot right here is -1. And so I'm going to look right here, and F prime is right there. So whatever height that is, a known height, but a positive value, right? I can also look on the F graph and the slope, it's going uphill, so it's positive. So right now, if I have to compare heights, I will, but I'm just saying that this is positive. And I have 2 ways of knowing that it's positive. By both using the F graph and the slope, right? The slope of the F graph, and it's positive, it's going uphill, and also using the height of the F prime graph, which it's up above the x-axis, so it's positive. Okay, now we're wanting to look at F double prime at 1, and here's where 1 is. Now, it won't be helpful to look at F. And so, at least right now, we don't know anything about F and F double prime going together. But what we do know is that F double prime is the slope of F prime. And so here is F prime. I'm going to follow it along, F prime, all the way over here to 1. Here's 1, and here's F prime. And so it's the slope of F prime, which I was trying to see if it was positive or it's negative. But actually, the slope of F prime, this is the F prime graph, looks to me to be very close to 0. And so the slope here is 0. So the slope of F prime, right here, F double prime, is the slope of F prime. So I just went on the F prime graph and went to 1, and said the slope is 0. So now I have something that's positive versus something that's 0, and it asked me which one was bigger. So this one is bigger. So I think that F prime at -1 is bigger, numerically bigger. If they would have both been positive, then I would have been, I don't know, getting out a ruler and trying to measure. And I don't know how I would guess the slope, what the slope would be. I would be really tough. then. Okay, problem 60 here is asking us to sketch the graph of the absolute x plus the absolute value of x. And we know by definition, and so I'm just going to write that right here, that the absolute value of x is either equal to x or to negative x. Negative 1, negative x, I meant. And that's if x is greater than or equal to 0. And this is if x is less than 0. So what we have about g, we have g at x equals x plus, and then it equals the absolute value of x. And that is either equal to x or to negative x, depending on what you have. So this is going to be piecewise defined. And in fact, I can make a piecewise defined right here. So since I can already see, okay, so x right here plus, and then it's either equal to x or negative x. So I'm going to put x. And this is if x is greater than, if x is greater, I wrote the x twice, if x is greater than 0. And then x, that's this x right here, plus, and then negative x. And this is if x is less than 0. So I'm just making it into a piecewise defined function here, and then I'll graph it. So this is g of x is equal to 2x, and that's if x is greater than or equal to 0, and 0, and that's if x is less than 0. So I'm going to make a sketch right here. So I have two things. I have above 0, I'm going to have y equals 2x. If I'm above 0, that's a line, so I can just pick 2 points. I'll pick 0, I get 0. It is defined at 0. And if I pick 1, I get 2. So 0, 0, and 1, 2. And then on this side, your y equals 0, and that is if you're smaller than 0. Now this, at 0 itself, this spot is already filled in. So I don't have to worry, because this is going to go here. You know, here is the horizontal line, y is 0. So maybe I should draw it in red. See it. I don't know that you can see that much better. Now, sometimes people say, well, how close does that get? Because shouldn't this be undefined because of this? But the other, this filled in that spot. So actually it goes all the way up to it. And you could pick points if you needed to verify that that's true. This pen is not writing. So that's the reason, is I'm just making an indentation on the graph. I'm not writing on the graph. So, okay, I've drawn. Am I still not writing on it? It won't write on that paper for some reason. I hate that. I don't know why it won't write on that paper. I have a different red pen. Okay. So they asked me for which values of x is g differentiable. And the only place that it's not differentiable is at the corner right there. And so it's not differentiable at x equals 0. So if I want to name the values that it is differentiable, I'm going to have to write it in either set notation or inequality notation, because it's not just one value, right? So it is differentiable from negative infinity all the way to 0, and then again from 0 to infinity. So just leaving out 0 is where it's not differentiable. Then they wanted me to find a formula for g prime. Now remember what g prime means. It means the slope. And so this is what the graph of g looks like from negative infinity to 0, right? And the slope right here, the slope is equal to 0. And then over here, the slope is equal to, now you remember we graphed that, right? It was y equals 2x. And so what is the slope of y equals 2x? Well, the slope is 2, right? Y equals mx plus b. So I didn't have to do any calculus. I didn't have to do any limit formula or anything like that, because I just had to know that what this is the slope. So g prime at x is equal to two things. It's either equal to 2. I'm just going to keep the story going here. It's equal to 2 if x is greater than 0, but not equal to 0, because remember, it's not differentiable at 0. So if I'm greater than 0, then the slope is equal to 2. And if I am less than 0, then the slope is equal to 0. It's a horizontal line, so the slope is 0. So we did a lovely job on that. We could have also used the limit definition and got crazy and found, if we would have done that, for this side over here, use the limit definition, the limit as h goes to 0 of f at, da 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 da, and could have showed that, hey, it's 2 over there if I would have wanted to. I don't know. I don't think that's what they were looking for. Here's some homework that you could give a try too. Okay, I think that's it for this video. Oh, wait, I have the homework there, so that means there's no more problems over here. That's true.